off probably like 6:10.
Start right.
I can, yeah, sure. I'll just go ahead and start now since we're.
Yeah, I think I'll be good bunch.
So we'll probably get kicked off about like 6:10. Let some more people like trickle in and stuff. My name's Austin. If you need anything, we've got Matthew and Robert today going to talk about comparing DynamoDB and DocumentDB. And yeah, we'll just give a couple minutes to like mingle, get some food, do whatever we need to do, and then we'll get like into the details about 5 minutes or so.
Cool.
Yeah, nice to see you guys.
Yeah, so.
Yeah.
I don't think so. I think he's a huge advocate. He also before that worked for data science. So I think he's very interested in cloud. Well, I think he's been very interested in space. He's like, everyone has a place in this. Everyone wins except for my customers. We're all wins. Yeah, I'm not just a grad dev. He's always looking for more things to add.
It should show you the stream here soon.
Yeah. We use Postgres for everything, and then in the past I did some things with Mongo, and that probably shows how long it's been since I did a bunch more games. Yeah. Cool.
I don't know. That's what I was asking about.
I'd love to see that implementation.
Yeah, yeah.
See how easy that can do. It's also not Coursera.
Huh. How do you spell it?
Coursera, Hasura. Specifically, it's Coursera, and he's running on Heroku. So I don't know if they're tied together.
Okay. Sounds like it's gonna be expensive bill at the end of the month.
Well, so the nice thing about this is that this was his call, it's an account. So as far as you know,
Just that.
that's fine. It's all it's not.
Do you do consulting then, or?
Yeah, so I'm independent contractor, and this particular is just a little consulting thing, so 5 to 10 hours.
Cool.
Just helping this guy so he can understand AWS technology and services and be more focused
Cool.
as he tries to build up this company.
Okay.
So an interesting project.
Yeah, that sounds fun.
I think there's going to be some more trouble. It's probably going to get into machine learning
Okay.
for the first time, which I've had that in a vendor.
Different.
Okay.
And just play around.
Cool. There was a talk that this meetup did a while back on machine learning stuff that was pretty interesting where they had somebody come in who
Yeah, I was thinking that.
okay. It felt like he was just throwing every single technology at it, but it was like, whoa, I didn't know we could do that. That's pretty sweet.
What's amazing about it is that I remember sitting there in that talk and I'm like, geez, I knew some of this stuff and I can't remember all
Yeah.
this stuff. I think he was dedicated
Yeah.
AWS guy who's holding that talk.
Yeah.
And then me and Mary had to really release a whole bunch of new stuff. And I'm thinking that guy is going to be exhausted if he's going to do all the extra stuff. The stage ranking tools and everything but I just had never had data that cared about machine learning.
Yeah.
So
Yeah.
I said,
One of my favorites was they did something with pictures where they could recognize like obscenities in the pictures, which I thought was really cool. Like, should this be allowed on Facebook? Yes or no? It feels like there's a lot of important value that could be used there that companies aren't taking advantage of. It looked like all you have to do is send them a picture and they will give you like thumbs up, thumbs down.
it's shockingly easy to smart intelligent or smart intelligent.
Yeah.
It's not cheap.
Yeah.
I heard horror stories of people who using that to turn something on overnight and came back with the files. Yeah, it can bite you. If you're not paying attention to what you're provisioning, you can easily end up with a 10K.
point. I wouldn't get your hopes too high.
I don't know, I try to have some human, I always try to say, like, some of the questions, I think people are honestly, this is to me, such, the tough part about this stuff is it tries to answer a question that's so situational.
Okay.
If you have to sit there and have to go in and someone say, well, we want you to come and tell us whether we should use DynamoDB. It's like, it's a talking before.
Yeah.
So I can't, we can't do justice.
Someone asked you for a
Yeah.
form?
Then how did this topic come up?
We were asking, so, yeah, so, he'll go and listen to Rob is one of the AWS
That's the important
the
part.
new position he held up last year, he's one of the
big shipping
members.
facility over on the Illinois side.
And as a data keeper, his job was to
Yeah, I
just,
think that's coming.
be a power in the community to speak for the
Microsoft,
good
too.
of AWS and database technologies. So he's much more into
It's
data
starting to
center
become a
and
set up.
that sort of stuff. He's on much more of the applications. I was applying
Good.
for
It's
it,
a-
but my specialty is that. So back in fall, they asked us to do this. So that's
Yeah,
kind of
absolutely.
I did very
encouragement from
like I've been here since 8 a.m. basic 9 a.m.
Yeah, it's kind of the Midwest too, where they rely on
It's
manufacturing so much.
sounds like a good thing.
And they're
But
trying
it's
to
also
kind of
like-
balance it out now, so they're back financially.
Like in the middle of the day, they kicked us all down here. So I've been in the
Sweet.
basement for probably
What do
9
you want to do?
Yeah. Free lunch. They had like Yampa sandwiches.
What's your favorite?
Oh no, that was upstairs. Downstairs. They like kicked everybody. So like they gave everybody who had to move free lunch. And I was fine with that.
Okay, excellent. For this talk, we'll have a lecture on the kind of basics. So, are we good?
Yeah, whenever you guys are ready.
Okay. It's that time?
Yep. Let me know if this ever like turns off.
Yeah, it's fine right now.
All right, good evening, everybody. My name is Matthew Bonig. So tonight we're going to be talking about DocumentDB versus DynamoDB. If you want to tweet about this or other social media, there's a hashtag for you. Just for the record now, I'm the guy on the left with the pistol, and that's Rob, falling to the superiority of DynamoDB.
Opposite.
So as I said, my name is Matthew Bonig. I am a software engineer here in the Denver area. I've been here for the last 15 plus years, mostly working for both enterprise and small medium businesses, mostly remote for the last few years. I am an application developer by trade for about the last 10 years, originally .NET for a long time, but then around 2015 I jumped ship and I went to Node. And I've been doing Node development and JavaScript and TypeScript in general pretty much ever since when I am doing developing. Otherwise, I'm either doing AWS architecture or DevOps type of work. I am a certified solutions architect. Woohoo. And if you want to follow me on Twitter, that's my handle @MattBonig. And something that a lot of people don't know about me, but if you've ever seen me talk before, you probably do already. My dream job would be to be a professional mascot. I think it'd be the greatest job in the world. I can't tell you how much I love watching like Benny the Bull and those guys do their thing. This was me a couple of years ago as an amateur mascot. I got to do this for about a year. In hindsight, it was kind of a bad idea. That suit, as you see, for one, my job was to escort kids from church service to Sunday school, and they hated that thing. It was so creepy and so scary, and most of them were really scared of me. But also, this thing was made really cheaply in a foreign country, and it was basically a hard hat, and the entire suit came off the hard hat. So it put all this pressure on my neck, and I didn't realize, because this was my first time being a mascot, like that's a really bad idea to put that much weight on your neck for an extended period of time, as you're running around and chasing kids and slapping them around and everything.
I'll stand over here so I can be seen. Hello, I'm Rob Koch. I just recently was named an AWS Data Hero. How, I do not know, but really, I've been involved in the community helping out with Deaf in the Cloud. I'd like to support disadvantaged populations getting into the cloud development scene. Right now, it's kind of in its infancy, so we'd like to take, those populations and get them in the picture. For software, I've been a software engineer and developer for 20 years. I started with VB4 way back when with mainframe.
Anybody, VB4? Anyone remember VB4? Sweet, too big.
You had to decide between 16-bit or 32-bit. At that time, I remember we had to decide which one we wanted to do, which box you wanted to install it on. So those were the days. But really, you can imagine how fast apps would be developed back then. Now, all this extra complicated DevOps, database management, all this other stuff going on now. The list can go on and on. But anyway, I'm the architect at S&P Global. I have several AWS certifications. I'm trying to acquire some more. You can follow me on Twitter. That's my handle, RobCube. I talk about databases, AWS, tech stuff that's coming up, some things about my personal life. So tonight our goal is introduction to NoSQL or NoSQL, where we're going from here, and then comparing the pros and cons of DocumentDB and DynamoDB. Hopefully there'll be no fights tonight, right? We'll compare costs,
There's no fight.
how cost effective each one is. And I'll turn it back over to Matt.
All right, so quick show of hands, just so we all are level-setted. Who here, do you know what NoSQL is? Raise your hand if you know what NoSQL is. Fantastic. Okay, so how about, have you had experience with NoSQL? Have you ever worked with it before? A little bit? Okay, who in here would say they're an expert in using NoSQL systems? All right, fantastic. So real quick, what are NoSQL databases? Well, being kind of cheeky, they're simply databases that don't have a query language or a structured query language. Something where you can do these random ad hoc selections of data in your system to say, give me only customers in Colorado or so on and so forth. Or what we call joins, if you've seen joins in your code before. These are databases that don't give you that option. You just don't have that power. They are largely and mostly key value stores, meaning that you are given a key or you give it a key and you get back a value. And that value may be extremely complex or it might be extremely simple. It doesn't matter to the system as a whole. Sometimes these are all called document stores. Document databases have been very popular for the last few years. Mongo, Cassandra. Cassandra's not really a document, but never mind. You probably heard of document database at some point. So those are all kind of your general NoSQL terms. But really in response, the question is what it's in. There we go. Okay. So AWS has got a lot of databases within their stratosphere, within their system. RDS, Aurora, Elasticache with either Redis or Memcache, all these different systems. We're just going to be focusing, and some of these could be considered NoSQL systems, by the way. But we're just going to focus on DynamoDB and DocumentDB tonight, and that's it. We're not going to talk about Route 53 as a database. Everybody knows that it's the world's greatest distributed database, but we're not even going to consider that as part of our NoSQL discussion tonight. So first off, why are we here? Why are we even talking about NoSQL databases? Well, like every continuation of technology, every step that we take in progress, it's usually in response to a very specific problem with our current technology. So we came up with writing because it turns out our brains are horrible storage devices. And then when we got writing down and we were writing down tons of information, and all of a sudden we found out the organization of it was really bad. So we figured out tabular data, and that helped us organize information better and read it better. And that was a response to just writing stuff down wasn't very useful. And this continues all the way until we get to where we're kind of at now with SQL systems and RDBMSs. These systems were designed in the early to late 70s. One of the primary things that they were meant to solve was the problem that storage was really expensive and compute was relatively cheap by comparison. Now, 50 years later, we have to respond to that because now that equation is flipped. Now compute is extremely expensive in comparison to storage, which is dirt cheap. Which means the way that we were modeling our data for years in a typical ERD type of style here, this is a general sort of, I think, off-the-shelf boilerplate from Microsoft of a database design. So we have orders, and then there's a join here to the order details, and then products are joined over to categories. And it's really efficient for storage, but it's really, really bad when you have to start getting all this data out of all these different places and munging it together. But we're not really here to try to tell you why NoSQL is good and what it's trying to fix. We're really assuming that you're already here because you want to use NoSQL and you're just trying to figure out of these two marquee solutions from AWS, which one is going to work better for you in your certain situations. But at the end, we're also just talking about storing data. That's really all it is at the end of the day. You may look at a data record like this. This is a typical document style data record and go, okay, that looks familiar, JSON, fine, no problems. Or you may look at it in a more tabular respect like this, but at the end of the day, it's still basically the exact same thing. Putting some curly braces or various things doesn't really change the equation much anymore. So,
I'm back. So now we'll talk about DocumentDB. It's not the Azure version. It's a derivative from MongoDB. It's very flexible indexing. For example, what Matt was just showing, the different document styles, how they're indexed in a subset or a range, you can index those, so that's pretty nice. The top level indexing plus the child level indexing. It's not available from the outside to the public. Some AWS database services like RDS or DynamoDB or Cassandra, those you can get access from externally, from your desktop straight to the database. This is a little bit tricky. It's not as straightforward in its accessibility. But it's a much better ecosystem tool. So same as what you would use with MongoDB, like I mentioned, and there are different tools and different tooling options, proprietary, open source, and those various sources are available. It's good support for programming language, C#, Java, you name it, it can handle it. You can store the files and the binary in DocumentDB. The compute and store process is separate, so you'll notice more and more that that's a trend, like in the AWS world. Databases used to have compute and store in the same instance, in the same processor, but now they're separated. So out of the box, everything's separated. That's one of the advantages of running MongoDB on your EC2 instance, for example, or on-prem. That's an advantage. And they just added the change streams, so you can write a program and you can watch it for changes and act on it. And now back to Matt.
Quicker than I thought that was. All right, so DynamoDB, in comparison, it's a fully managed service, which means that AWS built this thing from the ground up. And as such, it also means that they could build it to be extremely simple, which is really nice. If you're doing microservices, if you're doing little side projects or pet projects or things like that, you know, it's really nice to just be able to go in there and hit, here's a table I want, and you have you don't have to worry about compute or anything else like that. Because it's a ground-up system, the integration into the rest of AWS works out really nicely, especially when it comes to IAM, or Identity Access Management. Actually, I haven't said that one out loud in a while. I forgot what IAM stood for. And you get a lot of really strong policy control out of that. So you can even go on a per column basis. So you can say, well, this user only has access to these certain data points on a document, the name, the street address. They don't get to see a building total. Really nice for fine-grained control. DocumentDB has this as well, but now we've also got streams. Streams are a great way if you're building an event-driven system to be reactive to data changes in your system. It also keeps everything nicely separated and behind messaging protocols so that it's highly, highly reliable, and that's a really big plus. It does support time to live on records, so if you're running any sort of system where you know you can retire records after a given time, it's a really nice setup. You basically just give it a date, and it's off and running. It is very inflexible with indexing, though. That means that you're going to have to change the way that you write your data into the system, and that is problematic. It is a proprietary system, which means the ecosystem isn't as good, which means the client libraries aren't as robust. It means that in general, you can't port anything. Go take a Mongo application you wrote 5 years ago, you can run it on DocumentDB. You can't take a DynamoDB application and port it anywhere else without rewriting some code at some point. And there's no file or blob storage. AWS assumes you're going to just use S3. So at a very high level, just a few differences and comparisons between them. DynamoDB has been around for a while, I think 5-ish or so years now, and heavily productionalized. They were saying that during, Prime Day last year, DynamoDB, which backs that entire system, was doing 54 million transactions a second. That's more than most applications will ever see in their lifetime. It was doing it per second. It's absolutely amazing. It's been around. It's very, very tested and true. DocumentDB as a product from AWS is less than a year old, so there's still some growing pains there. There's still some things that are kind of coming around. And then there's the whole question about the split with MongoDB and stuff like that. They're both basically the same thing. A key value store and a document store really aren't fundamentally that much different. DynamoDB, if you want something that's really, really fast, easy to get started, and great at massive scale. Not necessarily cheap, but at least very effective at massive scale. DocumentDB is really good for existing deployments and pulling these things over, and pretty handy. If you're going to be migrating into these systems, if you're going to go migrating into DynamoDB, you're probably going to have to write your own routines for doing a lot of this. Mongo, again, if you're migrating from Mongo to DocumentDB, it's a backup and restore pretty much. Or you've got tons of third-party tools to get that data moved around. And finally, Proprietary, again, highly available, but DocumentDB is very tied tightly to the MongoDB ecosystem, things like that. And of course, that brings pluses and minuses along with it.
So we'll recap what we went through during our talk with the gotchas included, like how we work around things. I'll show you some screenshots if you want. I can play around with it in DocumentDB. On the left, you can download a program called Robo3T. It's a great tool for those of you who can't get away from SQL syntax. So you can write it in SQL here, and it will transform the SQL syntax to the MongoDB script. Mostly it's JavaScript, or it has that look to it. You can click on results and SQL query what you're looking for. That's what that looks like. It explains, maybe gives you some sort of hint or how to index that column, various things like that. So that's a nice tool. Robo3T is what it's called. The best tool that I've found when I play around with it.
3T.
And then when you're running queries and converting data, this is what it looks like. You can use CloudWatch and see it perform, how much you're using. It can read I/O. That's really important in the DocumentDB world. DynamoDB has its own RC2, WC2, write and reading credits, or capacity, thank you. But, there's the cost involved too, so that's CloudWatch there. Can show you something. I'm trying to think, where should I go? If I should go, do you want me to look more into like Robo3T, or would you prefer going with the gotchas?
Client's really cool.
Yeah, can we see the client?
Yeah, the 3T client.
Sure.
This is a long-running Mongo program. I mean, this isn't anything new to DocumentDB. This is one of those benefits from the ecosystem. I've used this tool 4 or 5 years ago for doing Mongo stuff, and it's a great tool. The SQL syntax is, I think, unique to them. So it's a fantastic way to get into these systems.
I wonder if I can zoom in. I don't think so. Sorry if you can't see it super clearly. For example, I could run something here. If I'm connected, cool. Sometimes the SSH, I can explain how there's a workaround for that, but in the setup to communicate with DocumentDB, but there's a workaround for that. So of course it disconnected now.
So this is so you can write SQL to query your database for Mongo?
So this query here, what it looks like in Mongo when you write it in SQL syntax.
So does it show you, if you write SQL, does it show you the other query as well? Like would it?
Yep.
Right.
Oh, that's awesome.
Yep. It'll show you MongoDB version. I can add where
that's
here.
cool.
It basically takes the SQL that you're used to writing and converts that into what the equivalent normal Mongo query can be.
Does it do it during build or?
This is just a tool that you would play around with. At the end of the day, if you wanted to use this in code, you'd copy and paste that code that it shows into your app.
Interesting.
Yeah, it makes it really nice to like kind of use this tool to figure out where your queries need to be and where you can get your data. And then when you're done, you just copy and paste and push that.
So you could take that and put it in your program. Start adding variables, and dynamically making changes right there. So it's a really great tool. There's different queries here. Some of them I can group them by time or various parameters. That query became pretty long. So you can see how terse SQL is really. I mean, it's just compared to Mongo when it's really, really long. So there's a shortcut. SQL is, I guess. It's a great shortcut.
It helps bridge that gap. If you're used to SQL, kind of lets you see, okay, if this is the SQL query I write, this is what the Mongo query would look like. It helps kind of bridge that gap. When you learn.
Same as when you generate indexing, you can see the MongoDB logic here. see if the query worked. Just waiting for the database. Yep, looks like it worked.
I can go in.
So I can go in and use the command line. And check it out. I can see the current operation. So if I have a long running query, for example, let's see if I can bring that up. I don't know why it's waiting for the database.
If y'all want, we could spend a half an hour going over this.
Well, I was gonna ask, just one question on this, so is this, all the way updated to, my understanding, I thought, and I had read that DocumentDB is based on Mongo, is it 3.6 or 3, something like that? And so now that
Correct.
Mongo's at
Yep,
4.0, is
3.6.
this still, like, does that change what we're seeing here at all?
There are some, I could explain more in the gotchas, so hold your thought.
Okay, fair enough.
Thank you.
Generally, yeah.
I got you covered.
It's about the same.
About the same.
There are some details there.
Got it, okay.
To now. What?
So 3.6 there, but the time to live can be kind of expensive. We count IO operations in that, so Dynamo TTL is free. No cost, right, in DynamoDB?
Yeah, it's just a delete operation.
So it can drop those records, but the IO processing, it tracks. So if you want to, get rid of a huge number of records, well, in Amazon, hold on, let me go back. In the Amazon world, you don't want to put too much in the database in Amazon because it'll cost you a lot of money. So people are looking for ways to cut costs. They can clean it out, clean out all the records that they're not using anymore. With Mongo or DocumentDB, the idea behind that is with TTL will cost money when you delete row by row, the IO. But the best approach, making a strategy, you could do a data collection for each table that maybe you have one month's worth of data in it, and then the next table has the next month's worth, and so on and so on. Every month you store the data. You can group it by date. And then when you're ready to drop the 2-year-old records, for example, like 2 years plus a month, you can drop that and do it, and there's no cost. So that's one strategy. Compared with DynamoDB, it's a little different. Okay? So Mongo 3.6, we're a little behind. Same with RDS sometimes. Like Postgres is a little behind, MySQL's a little behind. So we gotta give them time to catch up. But then again, if you work in a big company, it's very difficult in general to stay with the most latest and greatest. Amazon seems the same way. Now, even though it's 3.6, some functions are missing. The operators are missing. For example, XPR here, they're not supported. But mod got supported yesterday, so that's cool. So you can see that through the DocumentDB. You can see what's supported and what's not supported, but I could give you the website that this came from. There's the URL for it. So you can see Amazon and DocumentDB has like a list of what's not supported. Current keyword, yeah. Not supported currently, so it'd probably be coming, but see, here's some other examples. They're always working on it and always adding things that they support. Remember, DocumentDB is young. So, do we really do row level security? No, come on. We could talk about it, but what we're doing is the same concept as collections. We'll have one collection group for certain roles, and then you'll have another collection for other roles. Maybe both roles can see or write to it. Again, it's just depending on your strategy. So outside access, you can use PuTTY in the PC world. I don't know what you use in Mac. What do you use for SSH in Mac?
Just SSH.
Yeah.
Gotcha. That's the best way. But yeah, you can use PuTTY. That's what I mean. Not the other PuTTY, that PuTTY. So you can set up, that'll get you directly to DocumentDB through there. You have to set up an EC2 instance, like I showed you before. I can show you again.
Has anyone here done port forwarding before? Couple people, a little bit? Yeah, it's kind of an advanced technique. It basically allows you to use one machine as an intermediary. So you connect to one machine, and it sends all through your traffic over to the Mongo to DocumentDB. But it's not easy to get set up. In a lot of places it doesn't work, period. But it's necessary in this case.
I can do a brief thing here. I'll try my best. We'll set up a MongoDB with code. PuTTY's UI is not exactly the greatest, so bear with this and its quirks. So you set up an EC2 instance. There's the IP address. Same as that right there. You put it in there. You go into the SSH section. Click on off. And you can set up your private key there. So it has a private key. Then you can set up your tunnel ports here. That's just what they call it in here. And the destination is your DocumentDB cluster. So you can see the cluster name there. Put it in here. That's it. You get in, you have access to DocumentDB now. Sure.
Earlier you mentioned that DocumentDB is not public, so I'm guessing this is one reason and that it doesn't have a web interface like DynamoDB.
Correct.
Okay.
Not yet. Dynamo has just released a web table, something UI or something, right?
I'll tell you, yeah, it's
It's not there yet, right? Same with the catching up game. There's only so many people who work at Amazon, right? Good. You can reach out to me too anytime if you have more questions. Another gotcha for small scale projects, DocumentDB can be very expensive. But as a backup storage, it's really almost nothing. It costs almost nothing. I/O operations aren't that expensive. Like with DB, you have limitations, right? So if you have to scale up something quickly, DynamoDB will warn you that you're overusing it. DocumentDB doesn't seem to mind. So minimum, you're probably looking at $200 a month for DocumentDB operations. I can show you the calculations. But remember, storage and compute are separated in this tool, so that's one advantage that comes in. It's expensive to set up, but the performance is great. But then again, DynamoDB runs very cheaply, but you might want to back it up and replicate, and that costs money. So you can argue creative counting. They have a calculator here. You can pick different servers and how much memory you want. So I picked R5, the largest here. Or if you want maybe the fancy one here. Very expensive. $9,000 out of the box. You can do an older version, $200 there. So that's great. So we got $200 here. Storage is 18 gigabytes. That's pretty big. What would you call a good size database? What do you guys think? Give me a number.
Give me a number.
Like your database size. What'd you say? All right. $10 million I/O operation. That's a lot of data, a lot of traffic. But for 2 gigabytes, there might not be that much traffic. So the minimum here is 1. It's 40 cents per transaction. That's really cheap. So the storage is typically multiplied by 3. You're stuck with 200, it looks like. I don't think you can go lower than 200. So that's why the cost estimate for small scale projects is around $200. So that's great. Let's increase it to 36 gigabytes. We have a huge database. Supposing we have a lot of traffic. It's $5, it's not really that much. And then times 3. You can see my point though is that backup and I/O is not that big of a deal. It's not that bad. That's why the cost looks there. Pretty similar.
All right.
Back to you. See if you can beat that.
All right. So as we talked before, these are all kind of the big points. We'll go into a little bit more in depth. Really simple to get started with it because it's a fully managed service. If you want to create a DynamoDB table, you give it a name, you tell it what your primary key or your partition key is. And you can add additional stuff if you want, but that's basically it, and you have a table. You have a place to store stuff. And that's a great, easy way to get started. As far as the granularity and the security, he was saying how no one cares about row level security. People care about row level security. They also care about column level security as well, to say that certain users' roles only have access to certain parts of that record as well. Well, through IAM policies and other things, you can get really specific with that. You can find these things in a very, very well understood, very secure system like IAM. That's a big benefit to a lot of big enterprises. Streams are awesome. DocumentDB has them too, so I won't go into them too much, but basically the idea is that no matter what you do with an operation on the database, whether you're inserting a record or updating a record or deleting a record, a copy of that record gets pushed to the stream. And something else later on that stream, like an AWS Lambda function, can pick that up and do something with that data that's useful. Copy it to another system, change it in some way, send an email out to someone, whatever it may be. DynamoDB does have a time to live column. So you go in there and you tell Dynamo specifically when you create the table, this column is my time to live. And whatever that value is in there dictates when that record will go away. So this is stored in seconds since epoch, so it's a big 1, 5, 7, 7, whatever, big long, huge number. So you write your record with this value, and sometime later DynamoDB will automatically come through the system and clean these things out. Problem is that sometime later could be 5 seconds, it could be 5 days. There's no guarantee on it. So if your system is dependent on not showing this record once it's past that time to live, and this isn't just like a little cleanup thing that you're doing in the system, this is not a good system to use. So you have to be very specific that this is basically like, okay, I know the record's now copied somewhere else because it's two years old. I know I don't need it anymore because it's 2 years old. Let's just get rid of it. It's not a someone deleted a record, now let's go get rid of it out of the system by cheating. This is the biggest thing with Dynamo. Indexing is hard. Data modeling is hard in Dynamo. MongoDB is fantastic. You can throw pretty much anything at it and it'll generally work about the same. DynamoDB is not that way. You're going to have to be very specific about how you write your data to the database because the way you query it back out is very limited. We can only query anything from a table in DynamoDB if it is a value on that sort of root level of the document. If it's a column, it's not nested somewhere, nested deeper in that document. It also can only be a number, a Boolean value, or a text value, and that's it. You can't do compound indexes, which means you can't sit there and say, give me all the people who live in Colorado in the zip code 80112. That's a compound index. You're querying on two things, a state and a zip code. Can't do that in Dynamo. So now you have to model your data in such a way that the data represents those things together, and we can talk about that a little bit more. But it's a big pain. It's a big change from what we've been doing from database modeling for the last 4 decades. So there's a learning curve there. Finally, anytime you're going to create an index in the system, that's generally what's called a global secondary index, or a GSI. You'll probably create a few of these in the system, 4 or 5, depending on how things go. And they're just essentially another table. So you incur the cost of essentially another table. So when you start pricing out and you say, well, I'm going to be reading and writing this much data, and now you say there's a secondary index on that table, you just double that. And you might just triple that with a 3rd index, and so on and so forth. You can actually change those sort of parameters individually, but it doesn't work well if you do. This is a very proprietary system. Not only is it technically proprietary, meaning you can't take your DynamoDB code and go run it on Azure's cloud, but it also means that you're going to have to relearn a lot of things, and that the ecosystem just hasn't quite kept up with it. That Robo 3T tool that he was showing, it's a fantastic tool. If you're going to do any work with Mongo, I highly recommend you use that tool because it's going to save you a lot of time and trouble. Dynamo doesn't even come close when it has something like that. They've got an official tool out of AWS now called the NoSQL Workbench. It was released back in, I think, September or October, somewhere around there. It's still an early product and it has some very good value to it, but there's a lot of room to grow, especially when it comes to trying to query your data out of the system. Like Rob was showing, writing SQL, and you're doing that against Mongo and you don't have to do the conversion yourself. Oh, there's nothing like that on Dynamo. So if you like SQL, give that up. We don't get any sort of robust storage. I've got a couple websites that run off of Mongo, and it's really handy to be able to just store the very few graphic assets I have for that website within Mongo itself. And then just pull them out of Mongo rather than having to worry about a durable file store somewhere out on the file server. Big benefit there. With Dynamo, the best you can do is base 64 encode something and hope that it's under 400 KB. If it can't be base 64 encoded under 400 KB, got to shove it over to S3 and then just store a pointer to it. All right. The hardest part in a lot of these systems is trying to figure out what the price is going to be. Rob was showing you with DocumentDB how it's actually really, really flat. Whether you're starting off with a very small side project or you're running a pretty massive website, you pretty much know what your cost is going to be. It's a little bit harder with DynamoDB. Very similarly, you pay based on how fast you read and write data. You technically also pay for storage, but again, Like DocumentDB, that storage is really cheap. The first 25 gigs are free, and then it's like 25 cents a month per gig after that. So any project you're working on, you'll be fine for probably a long time. If you want to estimate out what your costs are going to be and you have to go through all the calculations, this is a great tool for doing it. It's called the DynamoDB calculator. You basically take a document that you've stored in DynamoDB that's representative of the average. You drop it into this tool and it goes 900 KB. And that's really cool because everything kind of in the Dynamo world focuses around 1 kilobyte of data. You basically pay for 1 kilobyte of data in chunks. When you say I want to write 5 kilobytes a second, that's your rate, right? So everything comes down to, well, how much is 1 kilobyte? Well, this is a document that I have in an actual database. At the top, I've just got a list of these objects right here. There's a category name, a list, a text, and a timestamp on each of these objects. And I just have a list of them, and there's another 8 of them collapsed over here. And that's part of this document. Also part of this document is another set of lists. This is just a string array over here, a couple of Boolean values, some more lists of objects and things like that. It kind of keeps going along. And I've got quite a bit of information here, and this is a little bit under 1 KB. So most of the time when you're dealing with a lot of sales order systems or ERPs or other sorts of things, you can get under 1 KB without much of a problem. So it doesn't actually end up being that hard to kind of calculate these things out. You do have these limits on storage, as I talked about. The hardest part is this learning curve, though. This idea that you're going to have to start changing the way you model your data so that you can get away with the limitations of a GSI and you can't do these deep queries like you can with Mongo. You are going to find yourself probably duplicating data in your system just to satisfy this. That's fine. If you have a good data layer, if you use event streams, you can do this at very, very little cost, so it's okay. Alex Debris is a gentleman who runs the DynamoDBGuide.com. He is also an AWS hero. He's a fantastic guy out of Omaha. If you don't follow him on social media, I highly recommend you do. He talks a lot about the DynamoDB. He put together this guide. It kind of goes through how you can model different data scenarios and those transitions from a traditional SQL system to a DynamoDB system. There's also Rick Houlihan. He is a principal engineer at AWS. He gives a talk every year at reInvent for the last few years about DynamoDB specifically, and it's a very advanced 400-level course. It's fantastic. His slides are available online, as well as the video itself. If you get into Dynamo and you do want to build these systems, I highly recommend you watch his video 5 times. Keep watching it over and over. I go back every few months. So what are the cost estimates? Well, again, we saw DocumentDB, it's really flat, right? It's generally $200 a month. So in our case, small internal app, 1 to 3 concurrent users. They're not doing much. They're not clicking around a lot. This is your side project at work or something like that. Minimum I'd go with is 5 read units and write units per second. And that'll cover a couple of units concurrently working, a couple of people working. And that'll cost you about under $3 a month. So very, very cheap, and technically that can go down. This will actually be under free tier in most situations too, so you may not have to pay anything for this. If you've got sort of like a B2B app or something that's got a larger set of users, but still not a public set of users where anybody can come and sign up, and you've got, say, 50 to 1,000 users or maybe 10 to 200 concurrent users at a time, well, that would probably get you about 200 on the read and the write units, I would estimate, and that's going to be about $115 a month for hosting that. And then finally, the web scale, like the really big ones, right? The 54 million transactions a second. This one was sort of interesting because I was trying to price this out, and I found out that if you want to go over 40,000 read and write units on a DynamoDB table, you have to get special permission from Amazon to do it. That's one of those safeguards they put into place. Be like, no, you do not want to rack up a $55,000 bill this month by provisioning this out. And so if you max them out, it's $23K a month. And if you're spending $23K a month on your database input and output, either the system's been horribly architected, or you don't care about spending $23,000 a month on your database system, so that's fine. So that's about it. Those are kind of the big contrasts between the two systems, why you may want to choose one or the other, some of the values and things like that. And now it is open for Q&A. Yes?
You talked about provisioned capacity.
Oh, yes.
What about dynamic capacity?
Right, so provision versus on-demand capacity in DynamoDB. when you're dealing with DynamoDB, often you specify, here's how much I think I'm going to be doing, reading and writing. And that's the more cost-effective method of doing it. But if you don't know, or if you have large spikes in your traffic, you may go with a different pricing model called on-demand. On-demand pricing, I actually didn't look up. I completely forgot that that was even an option because I haven't put it on my table yet. I did actually, during a little experiment here, turn on the on-demand provisioning and let it spike, and I'm really curious to see what my bill is going to be. So that actually leads good into, Rob showed you his awesome Mongo 3T tool, the great querying thing. I don't have anything that cool. DynamoDB, like I said, they have the NoSQL workbench. It's okay. There's another product I saw some people talking about last month that is a paid-for product. It's like $70 a month or something like that. I need to check it out. But because Dynamo doesn't have, they've been sort of niche for so long, that community hasn't sprung up to build really good clients. So what I'm going to show you is the web client that's in the AWS console. And please don't be mad at me for this. So this is if you go into the AWS console and you start looking at a table. In this case, this is called parking tickets. This is my parking tickets table here in DynamoDB. Ignore the other ones. Those are part of my own personal projects, and let's just hide all of those. Okay, so I'm looking at the table here. Some stats about this table right away. I loaded a bunch of data into it today. I got 622,000 records loaded into this table right now. So a pretty good amount. Not huge, not massive. I only loaded part of this particular data set, which was off of Kaggle, and it's the New York City traffic ticket data for like 3 years. I think it was like 8 gigs or something like that. I only loaded part of 2017 and for these 622,000 records. So anyway, this is a decent tool for coming in and taking a look at your data. It's, in my opinion, it isn't exactly a very snappy tool. It's not very responsive. You're going to probably get a little frustrated with it from time to time. But what I can do is I can come into this table and you can start to see here, there's some data that's showing up. This was this data that I loaded in from Kaggle. And if I want to, I can go through and just look at this. This is what's called a scan on this table, meaning that it basically just went to Dynamo and said, give me everything. And that's a really bad thing to do normally, but in the case of looking just at a few records, that's fine. If I want to run a specific query against it, first I have to make sure that index is already created, which means I had to have pre-planned running this query in some form or fashion. And we had identified 3 different types of queries that we had run against all of the traffic tickets that were written in the city of New York City. One is, what if we want to look at when the ticket occurred, like when the violation time was for the ticket. So this is like 10 in the morning or 12 in the afternoon, that sort of thing. So I come in here and I pick this index and then I have to say, well, what is the violation time that I'm looking for? And in this case, I have to be very specific. I have to say it has to be at like 10:45 in the morning. And that's represented in this particular data set with an A and then 10:45. And if I hit enter and I let this query run, you can see it actually ran pretty quick. And what I got back in here is first 100 items or so. Again, this was a query that it ran against essentially over 500,000 records, and it does it fairly quickly. But if you notice, if I want to look for violation times, I have to get really, really specific with this. This isn't a great query. You're never going to really do this. No one's going to sit there and say, well, I want to know all the tickets that occurred at 10:45 a.m. There's no value in that. I want to know all the tickets that happened in the morning, or maybe in the afternoon, or maybe between the hours of 10 and 11. But not that sort of specific time. And these are the sort of problems you tend to run into, is you have to get creative with how you set up and query your data. So if we take a look at another one of these indexes, in this case, it's the issue date and violation time. So I'm kind of doing a little bit of a compound index here. I said before that that's not really possible, but I cheated. It is actually a little bit possible. So this is a GSI on this table, which means that I have to provide an issue date at the very least. So I'll say 2017-04-21. Now I don't have to provide a violation time at this point. Even though it's part of the index, even though it's part of the query, I don't have to actually go to value. And if I don't, what I should get back from this are all tickets that happened on April 21st, 2017, in the order of their violation time. But I can additionally go in here and say, well, I want to get ones that occurred specifically at, let me just look for one that's actually going to return a record. Aha, great transition. Can you do between? Yes. So violation time. This one happened at 25 minutes after midnight. So if I come in here and do a 25, I should get back that one record. But again, I don't want to have to be that specific. So on a sort key, on the second part of the index, when you create an index, you have these two fields. In this case, issue date and violation time. I can say for the violation time, well, I want it to be greater than or equal to, or less than, or between two values, or that it just simply begins with something. So if I want to find out all the tickets that happened on the morning of April 21st, I just say, okay, and where the violation time just simply begins with the letter A. And now I should get back a bunch of records. So when I took all this data out of the New York City set and loaded it into the system, I had to actually start manipulating the data. For example, the issue date was not stored in a date sortable field like that. It was stored month, day, year in American format. But that's not string sortable. We want our things to be string sortable. So I had to write code during that migration to specifically swap those dates around. And specifically also on the violation time. The format in the data is actually the hour, the minutes, and then AM or PM. But again, I need to make this string sortable. It's a general rule of your queries. So I had to do that manipulation along the way. So when we were saying before that, migrating into DocumentDB from an existing Mongo, really simple. Migrating into DynamoDB from another data source, it's not very easy. And compound that with the fact that you're probably going to have to do this for millions of records because that's why you're going with a huge DynamoDB system. So I could keep going on and on about this. I don't want to pressure or make anyone feel uncomfortable looking at this awful, awful UI. So, yes?
So if you need to, having a little bit of experience with Mongo and just enough to ask this question about Dynamo, if your business expands over time and new requirements emerge, you can generally shoehorn whatever you need to into Mongo. How painful does it get in Dynamo to overcome an early architectural decision that turns out to not be the right one as you scale?
Right, so generally the principle that every piece of software you write is wrong. In that as soon as you write it and you get it out the door, you find out that you have to change it, right? That's a great question. You're right. One of the advantages of Mongo is that they have on-database queries that you can run. So you can manipulate the data on the database where it's more efficient, rather than pulling it down to some sort of service or client or something, read the data out, manipulate it, send it back. It's really slow and painful.
Not
that's
that
how
this
you
is a
fix
great
some
way to do everything,
Right.
but from the business perspective,
Yes.
they get it quick.
No, absolutely, and that is a completely valid way of fixing, a large part of these migration issues, these things that changed over time. Oh, well, we forgot to put a line 2 in all of these address things, and our code expects there to be one, so let's go shove one into all of our documents. You can do it, and it's not horrible. Dynamo, you don't get that. That's for sure. You would have to literally load every record out of the database, manipulate it, write it back. Or what's more typical is either, I would say, you write it into your application code to know to do that. So basically on the read, if it's not there, it then makes the change that you wanted. And then it can write it back to the database when possible, and it sort of does that rolling update on the fly as the records are needed. That's one approach to it. The other one is go with an event source data model, and then it's really not much of a problem at all. But the event sourcing data models are a whole nother discussion. Dynamo, these are going to be painful points for you, and most of the time what you're going to find out is that your application code that reads the records from the system is going to have to be aware of those changes over time and how to account for them.
Also, I would like to add, if you've already got MongoDB, then you can just stay with it. DocumentDB, it's the same kind of concept. You don't need to change your app code logic or anything like that. So that's why AWS came up with DocumentDB, so that will help support those who are in Mongo currently who want to migrate to the cloud.
And that's great, as long as they supported all the queries that you were supposed to have with Mongo, but since it's AWS, you don't get that. They're not quite there yet. DynamoDB is really limited, but at least that's a benefit for them. I mean, rather than having to support, 7 years of old system that's no longer touched. All right, any other questions? So, quick show of hands. I know Rob doesn't know I'm doing this. Raise your hand if you would rather implement DocumentDB going forward in future NoSQL systems. Okay, don't be shy. If you'd rather use DocumentDB, I'm not going to be hurt. Okay, who would rather use DynamoDB than DocumentDB? Where is it? Where's that sticker? Where's our special sticker? There you go. One guy on the DynamoDB side, fine, whatever. I love it. It's a great system. Just have to change things. Thank you very much. Appreciate everyone coming tonight. Thanks for listening to us, and we'll be around if you guys have got questions.
Thank you.